Hello there, this video will cover how to design and 3D print a cube from start to finish. This video will include procedures that will work on both Chromebooks and PCs. Near the end of this video, I will also include a procedure that will work on Android devices. And if you've ever wondered what happens when you create a video about 3D printing a cube, well, let me tell you. It involves a lot of cubes. So this video will show how to create a cube with either FreeCAD or OpenSCAD. Then I will show how to prepare the cube for printing with either Slic3r or Ultimaker Cura, and then we will 3D print the cube. By the end of it all, we will have a 1-inch cube. As a price estimate 3D printer-wise, the printer I used in this video is the Creality Ender 3 Pro, which as of right now, as I am making this video, costs around $200. This is a Media Blitz format that will allow me to share topics faster and keep pace with frequently updated topics. My channel focuses on adding the power of Linux to your Android, Chromebook, or PC without the need to root or remove your system. Additionally, I cover cross-platform topics. My playlists are available from the homepage on my YouTube channel and are organized by operating system and cross-platform topics. To make it easier to follow along with my videos, I include the full written instructions in the pinned comment. So if you scroll down to the comments of the current video you are watching now, you will see the top pinned comment containing the written instructions. To see the whole comment, click on Read More. Any updates will be noted at the top of the pinned comment. Note that you can copy and paste the notes into a text file like I have here with the mousepad text editor. Or, if you're feeling fancy, we can copy and paste the notes into a TiddlyWiki notebook, also known as Flexible Offline Searchable Notes. Here I pressed the backtick key from the top left of the keyboard so that there are 3 backticks before and after the text. This will apply monospaced block formatting. Keep in mind that you can modify the notes however you'd like, whether that's formatting, adding images, or changing what's in the notes. For more information on TiddlyWiki, I recommend watching my TiddlyWiki videos. That concludes the intro, now onward to the video. First, I'm going to give a quick overview on the process of 3D printing. First, we create a model with CAD software such as OpenSCAD or FreeCAD. CAD stands for Computer Aided Design. Once we've created our 3D design, we export the 3D model as a .stl file. STL stands for stereolithography. Then with the .stl file, we use a Slic3r program such as Slic3r spelled with a 3, Ultimaker Cura, and so on. With a Slic3r, we define how to print the layers of a 3D model by making configurations based on the model being printed and the printer we are using. Then when we are done preparing the model, we export a .gcode file. G-code stands for geometric code. The .gcode file is what we give a 3D printer in order to print out the 3D model. In this video, the goal will be to design and 3D print a cube from start to finish. Documentation will be shown near the end of the video. Here I have listed the timestamps for the major parts of this video. The first chunk of this video will cover software that will work on both Chromebooks and PCs, which includes FreeCAD, the Slic3r GUI, and Ultimaker Cura. After that, I will show 3D printing the cube. Then in the next chunk of the video, I will show software that will work on everything, including Androids, Chromebooks, and PCs. The software included in this section of the video will include OpenSCAD and the command line usage for Slic3r. After that, I will include where to get documentation for all the software shown in this video. Finally, depending on the 3D printer being used, it may be necessary to format the storage, which I will show how to do at the end of the video. To get started, we are first going to install some software we need to design and then prep the cube for printing. For this example, I will be using Synaptic Package Manager to install the software. To open Synaptic, we can go to the menu, and in the Preferences category, we can click on Synaptic Package Manager. When Synaptic is open, we can click on the Reload button from the top left to update the list of available software. When that's done, we can click on the Search button from the top right, and then we can search by name for FreeCAD. FreeCAD is the CAD software we will be using to design the cube. When FreeCAD comes up, we can right-click on it, select Mark for installation, click on the Mark button for the additional required changes, and then to install FreeCAD, we can click on the Apply button near the top left, and then we can click on Apply again to confirm the install. When that's done, we can click on the Close button in the Changes Applied window. Next, we are going to install a slicer that we will use to prep the cube for printing. If we'd like to use the slicer that's spelled with a 3 instead of an E, then we can click on the Search button from the top right, search by name for slicer spelled with a 3 instead of an E, and from here we can right-click on Slicer, select Mark for installation, click on the Mark button for the additional required changes, and then to install Slicer we can click on the Apply button, and click on Apply again to confirm the install. When that's done, we can click on the Close button in the Changes Applied window. Alternatively, another slicer we can use is Ultimaker Cura. To install Ultimaker Cura, we can click on the Search button from the top right, search by name for Cura, and when Cura comes up, we can right-click on it, select Mark for installation, click on the Mark button for the additional required changes, and then we can click on the Apply button to install Cura, and click on Apply again to confirm the install. When that's done, we can click on the Close button in the Changes Applied window. In order to resolve plugin-related issues for Ultimaker Cura, I am also going to install the Python package installer called pip, which I will then use to install TriMesh. If you'd like, you can try using Cura without installing TriMesh. To install pip, we can click on the Search button from the top right, and then we can search by name for Python 3-pip. Then from here we can right-click on Python 3-pip, select Mark for installation, and then we can click on the Mark button for the additional required changes. Then to install pip, we can click on the Apply button near the top left, and then we can click on Apply again to confirm that we want to install pip. When pip is done installing, we can click on the Close button in the Changes Applied window, and then we can close out of Synaptic. Again, I am going to be using pip to install TriMesh in order to resolve plugin-related issues for Ultimaker Cura. If you are not using Cura for slicing, then you do not need to install TriMesh. To use pip to install TriMesh, we can open a terminal, and from the terminal we can execute pip3 space install space TriMesh space -- break - system - packages. When that's finished, we can close out of the terminal. Now to create a 3D model of a cube, we are going to use FreeCAD. To open FreeCAD, we can go to the menu, and in the Graphics category, we can click on FreeCAD. From here we can wait a moment for FreeCAD to open. When FreeCAD is open, we can make it full screen by doing Alt F11 on our keyboard. To create a new FreeCAD project, we can click on Create New. To create the cube, we can first click on the Workbench drop-down from the top of FreeCAD, and select Part. Note that workbenches in FreeCAD are for different purposes such as sketching, building shapes from sketches, working with primitive geometric shapes, and so on. The Part workbench includes geometric primitives such as cubes, cylinders, spheres, and more. To create a cube, we can click on the Cube button. To see how to navigate the 3D preview of our model, we can hover over the Navigation Style drop-down from the bottom right, and this will show us how to navigate the 3D model. If we click on the Navigation Style drop-down, we can select a different setup if desired, such as selecting Touchpad if we are using a mousepad. For this example, I will be using the default CAD navigation style. To rotate the model, we can hold a middle click and then a left click, and from here we can drag our mouse to rotate the model. To pan the model, we can hold a middle click and then drag the mouse. To zoom in and out, we can scroll. To get an isometric view of the 3D model, we can click on the isometric button near the top that has a skeleton cube in it. Now we are going to resize the cube. To do that, we can go to the Model tab from the left side, select the cube, and from the property editor below we can set the length, width, and height. So from here we can triple click on the length, type in 1IN and press enter, and this will automatically convert 1 inch to millimeters. We can then repeat this by triple clicking on the width this time, type in 1IN and press enter, and this will convert 1 inch to 25.4 millimeters. Lastly, we can triple click on the height, and again we can type in 1IN for 1 inch and press enter for it to be converted into millimeters. Now that we've created a 1-inch cube, we can save our FreeCAD project by clicking on the Save button near the top left. And from here we can navigate to wherever we would like to save the file, as well as set the file name. For this example, I am naming the file cube and I am saving it in my home directory. Once we've set all that up, we can click on the Save button. Now to export our model as a .stl file, we can first select the cube from the left side in the Model tab. Then after we have selected our cube, we can go to the File menu and select Export. From here we can choose where to save the file as well as what to name the file. For this example, I will be naming the file cube. After that, we also need to click on the Files of Type dropdown, and from this list we can select STL Mesh. Once we've done that, we can click on the Save button. Now that we've designed a 3D cube with FreeCAD and have exported a .stl file, we can close out of FreeCAD by doing Ctrl-Q on our keyboard. So now we can use the .stl file to prep the model for printing. For this video, I will show how to prep the model for 3D printing with either Slic3r or Ultimaker Cura. So first, I will demonstrate using Slic3r. Slic3r can be opened from the menu, and in the Programming category, we can click on Slic3r. When Slic3r is opened for the first time, we will get the Configuration Assistant. With the Configuration Assistant, we can set some basic settings for the printer and the filament we are using. To get started, we can click on the Next button. The first setting is for the G-code flavor that the printer uses. Some places that we can find the G-code flavor we need are the box or the instructions the printer came with. We can also look at the printer itself, and finally we can search online for the G-code flavor the printer uses. For my example, I am using the Creality Ender 3 Pro, which uses the Marlin G-code flavor, so I am going to use the default setting of RepRap. RepRap in this case refers to the Marlin and Sprinter firmware. Marlin is a commonly used open source firmware that's based on Sprinter. Note that selecting the wrong G-code flavor can result in the printer interpreting the instructions incorrectly. Now with this particular version of Slic3r, using the back, next, and cancel buttons do not work. To work around this, if we clicked on the G-code flavor dropdown, we can unselect it by clicking on a blank space in the Configuration Assistant, and then we can press enter to get to the next step. Note that if you accidentally close out of the Configuration Assistant, or if you want to start over, then it can be reopened by going to the Help menu in the Slic3r window, and select Configuration Assistant. Now for the next setting, we have the bed size. Here we can select the shape of the printer bed, and we can set the size in millimeters. To figure out the bed size of the printer we have, we can look at the box or the instructions that the printer came with, or we can measure the bed size. Again, I am using the Ender 3 Pro, which has a bed that is 220mm by 220mm. Once we've entered in our bed shape and size, we can press enter to continue. From here we can enter in the diameter of our printer's nozzle in millimeters. For the Ender 3 Pro, I am entering in 0.4 millimeters. Some places we can find the nozzle diameter are by looking at the instructions or the box the printer came with. We can also look at the printer itself, or we can search online for what the nozzle diameter of our printer is. Once we've typed that in, we can press enter to get to the next step. So next we have the filament diameter. To find the diameter of the filament we are using in millimeters, we can look at the spool of the filament we have. We can also look at the box the filament came with, or we can measure the diameter of the filament with a caliper. So for my example, the diameter of the filament I am using is 1.75 millimeters. Once we've typed that in, we can press enter to continue. Next, we have the temperature for extruding the filament. Depending on the type of filament we are using, we may need a lower or higher temperature. The default temperature in Slic3r is 200 degrees Celsius, which works for PLA plastic. Other materials such as ABS plastic may require a different temperature. Once we've set the extrusion temperature in Celsius, we can press enter to continue. Finally, if the printer has a heated bed, we can also set the bed temperature for our printer. And again, depending on the type of filament we are using, the temperature may vary. For my example, I am using PLA plastic, so I am going to set the bed temperature to 60 degrees Celsius. If your printer does not have a heated bed, then you can leave this as is with the setting set to 0. When we are done setting the bed temperature, we can press enter, and then we can press enter one more time to finish. So now we are done with the configuration assistant. In order for the changes to be applied, we need to restart Slic3r. So we can close out of Slic3r, and then we can reopen it from the menu, and in the programming category, we can click on Slic3r. From the right side, we should now see the print, filament, and printer settings are set to My Settings. Now to add the 3D model of our cube, we can click on the Add button near the top left, select the .stl file, and then click on the Open button. Once we've added the model, we can zoom in and out by scrolling. Then to rotate, we can hold a left click and then drag the mouse. Finally, to pan the model, we can hold a right click this time and then drag the mouse. Now if we click on the cube, we can see the size near the bottom right. For this example, the size should be 25.4 by 25.4 by 25.4. In Slic3r, 1 unit equals 1 millimeter and 25.4 millimeters is equal to an inch. So from here we can see that we will have a 1-inch cube. Now in Slic3r, with the model selected, we could do various transformations by clicking on the buttons from the top. For this example, we are going to leave the positioning, size, and everything else as is. In Slic3r, to get to the different settings, we can go to the Settings menu, and from here we can view the Print Settings, Filament Settings, and Printer Settings. The print settings are for setting options that we specifically want to use for the model being printed, such as supports, infill, layer height, and so on. The filament settings are for setting options related to the filament we are using, such as the filament diameter, the temperature for the extruder, and the temperature for the bed. Finally, the printer settings are for setting options that are specific to the printer we are using, such as the nozzle diameter. The only change we are going to make are the loops for the skirts. These skirts help to get the filament flowing so we have a better first layer when we are printing. To set the skirts, we can go to Print Settings, and from the list on the left side, we can select Skirt and Brim, and from here we can set the number of loops to 5. Note that you can use more or less loops. Now if we close out of the Print Settings tab, we will see the list of custom options we have set on the right side. Note that if we wanted to get rid of an option that we have set, we would click the red circle button to the left of the option. Now to see a preview of how the layers will be printed for our model, we can go to the Preview tab from the bottom left, and here we can see how the model will be printed. Note that the loops around the model are the skirts. To see what the layers will look like, we can drag the slider on the right side. When we are ready to export a .g-code file, we can click the Export G-code button from the right side. From here we can choose where to save the file as well as what to name the file. For this example, I'm going to leave the file name as is and I'm going to save it to my home directory. Once we've done that, we can click on the Save button. And now that we're done with Slic3r, we can close out of Slic3r. If we have set custom options that are not saved into a configuration file, Slic3r will ask if we want to save them to our configuration file. For this example, we can just click the Discard button to discard the changes. So now we can use our .g-code file to print our model. Alternatively, we can prep the model for 3D printing with Ultimaker Cura. To open Ultimaker Cura, we can go to the menu, and in the Programming category, we can click on Ultimaker Cura. From here we can wait a moment or two for Ultimaker Cura to open. Now the window being too big should generally be a non-issue. On the other hand, if you do encounter the window being too big, a simple fix that we can do is change the default font size in the desktop so it is smaller. If you happen to be using a Chromebook, you can also use the scaling script to increase the desktop resolution. So first I am going to close out of Ultimaker Cura by doing Ctrl-Q on my keyboard. Then to change the default font size in my desktop, I am going to the menu, and in the Preferences category, I'm going to click on Customize Look and Feel. Then in the window that comes up in the Widgets tab, I am clicking on the default font that is currently being used, and here I am decreasing the font size. Once I've done that, I'm going to click on the Apply button to apply the change. Now that I'm done doing that, I'm going to close out of Customize Look and Feel, and then I'm going to reopen Ultimaker Cura by going to the menu, and in the Programming category, I'm going to click on Ultimaker Cura. Now this time when I open Ultimaker Cura, I can see the whole window. To make Ultimaker Cura full screen, we can do Ctrl F11 on our keyboard. Now we can go through the initial setup. So from the Welcome dialog, we can click on the Get Started button. After that, click on the Agree button. Then click on the Next button. And for the Sign In to the Ultimaker platform, we can click on the Skip button. Now for adding a printer, we can click on the Add a Non-Networked Printer dropdown. And from here we can find and select our printer from the list. For this example, I am using the Creality Enter 3 Pro, so I'm going to click on the Creality 3D dropdown, and then I'm going to select Creality Enter 3 Pro. If your printer is not in the list, then I recommend going to the website for Ultimaker Cura, which I will have linked in the pinned comment. Once we have selected our printer, we can click on the Next button. From here we can double check the settings for our printer. So in the Printer tab, under Printer Settings, we can check that the bed size and the bed shape are correct. Some places where we can find the bed size are in the instructions or the box the printer came with. We can also measure the size of the bed of our printer. And finally, we can search online for the specs of our printer. After that, if our printer has a heated bed, then we can make sure that the heated bed option is checked. Finally, under the printer settings, we can check that the G-code flavor is the correct one for our printer. Using the wrong G-code flavor can result in the printer interpreting the G-code incorrectly. Some places that we can look to find the G-code our printer needs is by looking at the box or the instructions that came with the printer. We can also look at the printer itself, or we can search online for what G-code flavor our printer uses. Now next to the printer settings, we have the printhead settings. The one thing we can check here is that the number of extruders is set to the correct amount. The printhead settings are mainly for if we wanted to print multiple models at once, where we would have the printer completely print each model at a time rather than printing every model at once layer by layer. Since we are only printing a single cube, we won't need to worry about these settings. Below the printer and printhead settings, we have the start and end G-code, which affect the behavior of our printer when it starts and finishes printing. Depending on the printer that has been selected, this may vary or it may not be filled out at all. For this example, we do not need to modify this. Finally, we can go to the Extruder tab, where we can verify that the compatible material diameter matches the diameter of the filament we are using in millimeters. To figure out the diameter of our filament, we can look to see if the diameter is written on the spool of the filament. We can also see if it's written on the box the filament came in, or we can measure the diameter of the filament with a caliper. When we are done verifying all those settings, we can click on the Next button, then click on Next again, and here we will be shown the release notes for the version of Cura we are using. When we are done looking at that, we can click on the Finish button. Now to add our 3D model, we can click on the button with the folder icon from the top left, and then we can select the .stl file for our cube. Once we've selected our file, we can click on the Open button. Now to navigate the model, we can hold a right click and then drag the mouse to rotate. Then to pan the model, we can hold a shift and then a left click and then drag the mouse. In addition to that, we can zoom in and out by doing either Ctrl+ or Ctrl- on our keyboard. Now if we'd like a sort of reset with our view, we can click on the 3D View button from the bottom left. Now in Cura, if we click on the model, we can then use the menu from the left to do various transformations such as moving, rotating, resizing, and more. For this example, we're going to leave everything as is. Note that if we want to add a printer or change printer-related options, then we can click on the drop-down with the name of our printer, and then we can click on the Manage Printers button. Then from here, if we would like to change the settings for our printer, we can select our printer, click the Machine Settings button, and from here we can modify the options for our printer. Here I'm going to leave everything as is, so I'm going to close out of the printer settings, and then I'm going to close out of preferences. Next to the drop-down with the name of our printer, we have the Custom drop-down. From here we can set the material so it matches the material of the filament we are using. For my example, I am using PLA plastic, so I'm going to leave the material set to PLA. After that, we can verify that the nozzle size matches the diameter of the nozzle in millimeters for the printer that we are using. Some places where we can try to find the nozzle diameter of the printer we are using are by looking at the instructions or the box the printer came with. We can also look at the printer itself, or we can search online for the specs of our printer. Now in Cura, next to the Custom dropdown, we have the Print Settings dropdown where we can set various options based on the model being printed. Some different options include the layer height, which impacts the quality, the amount of infill, whether or not we want to print with supports, and more. To see more options that we can set, we can click on the Custom button from the bottom right, and then from here we can click the 3-line menu, select all, and now we can see a list of all the different options that we can set. For this example, we're going to leave everything as is. Now when we are ready to slice our model, we can click on the Slice button from the bottom right. Then when the model is done being sliced, we can click on the Preview button to see what the layers will look like. When we are looking at the preview, we can drag the slider from the right side to view how the different layers will be printed. Note that the loops around the cube are skirts. This helps with getting the filament flowing so we get a better first layer. In addition to seeing the individual layers, we can click on the Play button from the bottom of the window, and this will give us an animated preview of how the layers will be printed. When we are satisfied with how everything is set, we can click on the Save to Disk button from the bottom right. From here we can choose what to name the file as well as where to save it. For my example, I'm going to leave the file name as is, and I'm going to save the file in my home directory. After that, we can click on the Save button. Then to close out of Ultimaker Cura, we can do Ctrl-Q on our keyboard. So now we can use the .g code file to print the model. Now we can 3D print the cube. For my example, I am using the Creality Ender 3 Pro printer, which I've had for a few years. Keep in mind, your printer may vary on the procedure needed to prepare for printing. So this is just a general example of how I prep the Ender 3 Pro. So depending on the printer, you may need to level the bed manually. So for my printer, I am first having it auto home so that I can start leveling the printer. After that, I disabled the steppers so that I can move the nozzle and the bed freely without resistance. So in order to level the bed, I need to turn the screws with the gears on the bottom. So near the 4 corners of the printer, I am checking and adjusting the level based on the resistance I get from putting a piece of paper between the nozzle and the printer bed. Ideally, I'm trying to make it so that the nozzle is lightly scratching the paper. So there shouldn't be too much resistance, but the nozzle should also be touching the paper. After that, I moved the printer head up on the Z-axis, and then I started preheating for PLA filament. PLA plastic is a common printer filament. If you're using a different material such as ABS plastic, then you'll need to preheat with a different temperature. If the printer has been used before, some filament will likely come out when preheating. This is why I moved the nozzle up so that it's easier to grab the filament that oozed out. With that being said, do not touch the nozzle, it is very hot. I like to use a pair of pliers to grab the filament once it's done oozing out so that my hand isn't anywhere near the nozzle. Once the printer is done preheating, I then extrude 10 millimeters of filament to ensure that the filament is flowing and to also get a better first few layers for the print. Again, I am using pliers to grab the filament that's been extruded. Now when we are done prepping our printer, we can plug in our external storage device containing the .g code file into our printer, and then we can select our file from the external storage device to start printing. So now we can sit back, relax, and watch the printer go. Note that the loops around the cube are the skirts that we set up when we sliced our 3D model. When the printer is finished, we can remove our cube and the skirts from the printer's bed. If there is a struggle to remove what we printed off of the bed, then we can try using a scraper of some sort to get it off. For this, I prefer to use a plastic scraper if possible. If there is a stray plastic-like hair where the printer finished, we can cut that off by using scissors, wire cutters, or we can even just pull it off with our fingers. So now we have successfully designed, sliced, and 3D printed a cube. Now how fun is that? Next, I will be using an Android device to create and prep a 3D model for 3D printing. Again, this procedure will also work on Chromebooks and PCs. In order to create the 3D model and prep it for printing, we can first install OpenSCAD and Slic3r. For this example, I will be using Synaptic Package Manager to install OpenSCAD and Slic3r. To open Synaptic, we can go to the menu, and in the Preferences category, we can click on Synaptic Package Manager. Then when Synaptic is open, we can click on the Reload button near the top left to update the list of available software. When that's done, we can click on the Search button near the top right, and then we can search by name for OpenSCAD. When OpenSCAD comes up, we can right-click on it, select Mark for installation, and then click on the Mark button for the additional required changes. Then to install OpenSCAD, we can click on the Apply button, and then we can click on Apply again to confirm the install. Note that on Android, we can generally ignore install warnings and errors. So if we are using Android and we get an error, we can click on the Close button in the error window, and then we can click on the Close button in the Changes Applied window. Now to install Slic3r, we can click on the Search button again, and this time we can search by name for Slic3r spelled with a 3 instead of an E. When Slic3r comes up, we can right-click on it, select Mark for installation, then we can click on the Mark button for the additional required changes. And finally, to install Slic3r, we can click on the Apply button, and then click on Apply again to confirm the install. Again for Android, if the install ends in an error, we can click on the Close button in the error window, and then we can click on the Close button in the Changes Applied window. Now that we are done installing software, we can close out of Synaptic. Now we are going to create a 3D model of a cube with OpenSCAD. To start up OpenSCAD, we can go to the menu, and in the Graphics category, we can click on OpenSCAD. Then from the Welcome window, we can open one of the examples by clicking on one of the drop-downs in the Examples list, and select an example. For this example, I clicked on the Advanced pull-down, and then I selected Children.SCAD. Once we have selected our example, we can click on the Open Example button. Now for Android, if maximizing the window crashes OpenSCAD, then what we can do is drag out the corner of the window slowly to see how big the window can be made before it crashes. Once we figure out the point at which OpenSCAD crashes, we can open OpenSCAD again. Then from the welcome window, we can click on the example we opened before from the list of recents, and click the Open Recent button. And then this time when we drag out the corner of the window, we can drag it out just before the point at which OpenSCAD crashed. Now in OpenSCAD, we can close out of the extra windows, which include the console, error log, and customizer windows. So now we have more room for the editor and preview windows. We can also resize the windows by dragging the edges of the windows. Note that the extra windows we closed can be opened again by going to the Window menu, and then we can uncheck Hide Console, Hide Error Log, and Hide Customizer. Now for the 3D model, we can rotate it by holding a left click and then dragging a finger on the mouse. To pan the model, we can hold a right click this time and then drag a finger on the mouse. To zoom in and out, we can click on the Zoom In and Zoom Out buttons near the bottom left of the preview window. To reset the view, we can click on the Reset View button that has a circular arrow in it. Now OpenSCAD uses code for 3D design. For example, to change the color of the cubes to purple, we can go to the 7th line in the editor, and then we can change the word red to purple. To see the change take effect, we can click on the preview button that has a cube and 2 arrows in it. From here we should see the color of the cubes change to purple. Now that we understand the general idea of OpenSCAD, we are going to create a cube. To do that, we are first going to click on the New File button near the top left of the editor window. After that, we can close out of the example, and click on the Discard button if we made any changes. Now for the new file in the editor window, we can create a cube by typing in cube left parenthesis 1 comma space center space equal sign space true right parenthesis semicolon. This will create a cube that is 1 unit in length, width, and height, and it will also be centered. Keep in mind that OpenSCAD is unitless, so we will define size later when we prep the model for 3D printing. In order to see what we created, we can click on the Preview button at the top of the editor window. Then to see the cube more clearly, we can click on the Zoom In button at the bottom of the Preview window. So now we have created a 3D model of a cube. To save our project, we can click on the Save button near the top of the editor window. Then from here we can choose where to save the file, which for my case I will be saving the file in the home directory. And then we can also name the file. For my example, I will be naming the file cube.scad. After that, we can click on the Save button. Now in order to export the 3D model as a .stl file that we can use to prep the model for printing, we first need to render it by clicking on the Render button near the top of the editor window. The Render button will have a cube and an hourglass in it. Since the project only contains a cube, this will be instantaneous. For larger projects, it may take a few moments. Once the model is rendered, we can click on the Export as STL button. From here we can choose where to save the file as well as name it. For this example, I will be naming the file cube.stl. After that, we can click on the Save button. And now that we're done creating a 3D model of our cube, we can also close out of OpenSCAD. Here I am just opening a file manager where we can see I have a file called cube.scad and I also have a file called cube.stl in my home directory. Now we can use the .stl file to prep the model for printing. To do that, we will be using Slic3r. Because Linux on Android currently cannot use OpenGL graphics, we will use Slic3r from the command line. Again, this procedure will also work on Chromebooks and PCs. To use Slic3r from the command line, we start the command with Slic3r, which is spelled with a 3 instead of an E, and then we follow that up with the options we want to use for this print, and finally we end it off with the .stl file of the model we want to print. For this example, I will be creating a script for using the Slic3r command. This can provide a way of remembering what configurations we've used before so we don't forget later on, and then we also don't have to retype every option we want to set. Note that you do not have to create a script in order to use Slic3r. To create the script, we can execute nano space gocube. This will create a file called gocube with the nano text editor. From here, for the first line, we can type in Slic3r spelled with a 3 instead of an E, space backslash. So here we will be executing the Slic3r command, and the backslash will continue this line onto the next one. Note that the backslashes are not necessary and everything can be executed as one line. For readability and clarity, I will be using backslashes. So on the next line, we can type in -- scale = 25.4 space backslash. .stl files are unitless and Slic3r assumes 1 unit is 1 millimeter. So in order to get an inch, we would need 25.4 millimeters. So for this example, we are creating a 1-inch cube by setting the scale to 25.4. Now on the next line, we can type in -- skirts = 5 space backslash. This will print out 5 loops of filament surrounding the object being printed. This helps with getting the filament flowing beforehand, so there's a good first layer. Note that you can use more or less skirts. After that, on the next line, we can type in -- nozzle -diameter = the diameter of the printer's nozzle in millimeters space backslash. This defines the nozzle diameter of the printer we are going to be printing with in millimeters. For my example, I am using the Ender 3 Pro, which came with a 0.4 millimeter nozzle. Some potential places you can try looking from to figure out the diameter of your printer's nozzle are in any instructions that came with the printer, the box the printer came in. You can also look at the printer itself, or you can search online for the specs of your specific printer. Once we have that set, on the next line we can type in -- filament -diameter = the diameter of your filament space backslash. This defines the diameter of the filament we are using. To figure out the diameter of the filament we are using, we can look at the spool of the filament to see if it's written on there. We can also look at the box the filament came in, or we can try measuring the filament with a caliper if you happen to have one on hand. Note that depending on the filament being used, you may need to set the -- temperature option in Celsius. The default temperature is set to 200 degrees Celsius, which works for PLA plastic, which is a common filament. Another common filament is ABS plastic, which requires a higher temperature to be used. Note that there are other kinds of filament, such as nylon and carbon fiber. Additionally, you may need to set the G-code flavor with the -- G-code - flavor option. Using the wrong G-code flavor can result in the printer interpreting the G-code instructions incorrectly. The default G-code flavor in Slic3r is set to RepRap. RepRap in this case refers to the Marlin and Sprinter firmware. Marlin is a commonly used open source firmware that's based on Sprinter. To find the necessary G-code flavor, we can look to see if it's written anywhere on the printer. We can also look at the instructions the printer came with, or we can search online for the G-code flavor the printer needs. For a list of G-code flavors available in Slic3r, we can do man space Slic3r spelled with a 3 instead of an E from a terminal. And from here we can scroll down to the printer options section and look at the available options for -- G-code - flavor. After that, for the next line, we are going to type in -o space / mycube.gcode space \. This lets us define where to save the file as well as what to name the file. Note that this option is optional. By default, Slic3r will save the file in the same directory as the STL file, and it will have the same name as the STL file, except the file type will be a .gcode file. Finally, after that, on the next line, we can type the name of the .stl file, which for this example is cube.stl. Note that we can input more than one .stl file at once. When we are done creating the script, we can do Ctrl-O, Enter, and Ctrl-X to save the file and exit Nano. Then from there we can execute chmod space plus x space go cube. This will make our script executable so that we can use it. Now to execute our script, we can do /go cube. In the output, we will be shown where the file has been saved, and we will see the file name. So here I can see the file is in my home directory, and the file is called mycube.gcode. So from the home directory, if we execute ls to list the files and folders, we should see the mycube.gcode file. So now we can use our .gcode file to print our model. For Chromebooks and PCs, the .gcode file can simply be copied to an external storage device. For Androids, we need to use a specific file path in order to copy the .gcode file directly from the Userland app to an external storage device. To do that, we first need to shut down Linux. To shut down Linux, we can click on the three-dot menu from the VNC floating menu, select Disconnect, then go back into the Userland app, right-click on the session we are using, select Stop Session, and after that we can go to the app's overview, and then swipe out the Userland app. Now before we start Linux back up, we can plug in our external storage. When using external storage on an Android, the file path for an app will only be automatically generated when an app is first opened while the external storage is plugged in. This is why we had to shut down Linux and close the Userland app. Now with the external storage plugged in, we can open the Userland app again, then we can start up our Linux session, and then we can start our desktop back up. Once we have our desktop up and running again, we can open up a terminal, and from here we can execute cat /proc/mounts pipe grep vold. In the output of this command, next to /mnt/media_rw/, we should see the storage ID for our external storage. If there are multiple external storage devices plugged into the Android, then there will be multiple external storage IDs. Once we know our external storage ID, we can highlight it, do Ctrl-Shift-C to copy it. Then after that, we can open up a file manager, and then we can go to /host-rootfs/storage/the external storage ID, which we can paste by doing Ctrl-V. And after the external storage ID, we can type in /android, starting with a capital A, /data/tech.ula/files. From here, I recommend bookmarking the file path for convenience. If we are using File Manager PCman FM, then we can do Ctrl-D on our keyboard to bookmark the file path. Once we've done that, we can go back to our home directory where our .gcode file is located. And before we copy the file, we can first right-click on the file, select Properties, then in the File Properties window we can go to the Permissions tab, and from here we can set all the access control dropdowns to anyone. Once we've done that, we can click on the OK button. Now with the .gcode file selected, we can do Ctrl-C to copy it, then we can go to the file path that goes to our external storage, and then we can do Ctrl-V to paste the file. Once the file is copied over, we can eject the external storage by pulling down our notifications. Then for the external storage device, we can click on the Eject button. When viewing the external storage from another device, such as the 3D printer, we can get to the .gcode file by going into the Android folder, then go into the Data folder, and after that, go into the tech.ula folder, and finally, we can go into the Files folder where the .gcode file will be located. For documentation on FreeCAD, we can open up FreeCAD, and then from FreeCAD in the Help menu, we can select FreeCAD Website. This will take us to the official FreeCAD website. From here we can get downloads for different platforms, documentation, and news on what's new with FreeCAD. In addition to that, if we go back to FreeCAD and go to the Help menu, we can select Users Documentation. This will take us to the FreeCAD Wiki. From the User Hub part of the Wiki, if we scroll down, we can see the links to the parts of the Wiki that document the workbenches for FreeCAD. To navigate to different parts of the FreeCAD wiki, we can click on the 3-line menu from the top left. And from here we can see that the wiki includes extensive documentation, lots of tutorials, really cool screenshots, and more. Finally, if we go back to FreeCAD and then go to the Help menu, we can select FreeCAD Forum. This will take us to the official FreeCAD forum where we can ask questions related to FreeCAD. For more information about OpenSCAD, we can go to openscad.org. Here we can go to the documentation page where we can see there's tons of documentation. So first, there's the OpenSCAD tutorial, which walks us through various examples and explanations of how to use OpenSCAD. After that, we have the official OpenSCAD user manual. From here we can see the ins and outs of how to use OpenSCAD. In addition to that, at the bottom of the documentation section, there's a cheat sheet. To save the cheat sheet, we can either take a screenshot or we can print the page to PDF. If we print the page to PDF, then I recommend setting the orientation to landscape. Here, after I've saved the cheat sheet as a PDF, I opened it with QPDF View. To get QPDF View, we can install QPDF View. Besides the official documentation, they also have links to books on OpenSCAD. One book that caught my attention was the Mastering OpenSCAD Within 10 Projects. This is an online book that we can read at no cost. This book explains and has examples which include this really cool looking pen holder, a whole intricate tree, and more. Also, in the documentation section of the OpenSCAD website, they have a couple of links to video tutorials. Here I clicked on the first one, which takes us to a playlist of OpenSCAD videos that get more complex as we go. Finally, from the OpenSCAD website, they also have links to articles for their documentation. For documentation on Slic3r from the command line, we can do Slic3r spelled with a 3 instead of an E, space -- help. This will give us a more brief form of the documentation for Slic3r. From here we can also see what the default value is set to for each option. To get more detailed documentation, we can do man space Slic3r spelled with a 3 instead of an E. If we'd like, we can take what's in the man page and put it into a text file so that we can search it. To exit out of the man page, we can press the Q key. Then to put the man page into a text file, we can execute man space Slic3r spelled with a 3 instead of an E, space right angle bracket, space Slic3r spelled with a 3 instead of an E, -doc.txt. This will take the output of the man Slic3r command and put it into a text file called slicer-doc.txt. So now if we open a text editor such as Mousepad and then open the slicer-doc.txt file we created, we can see the output of the man Slic3r command has been put into a text file. So if we're using the Mousepad text editor, we can do Ctrl F to do a find on whatever word we would like. For my example, I searched for filament-diameter and we can see the filament-diameter option that we used earlier. So this gives us an easy way that we can search for different options for Slic3r. Keep in mind you can modify the text file however you would like. For more documentation on Slic3r, we can go to Slic3r spelled with a 3 instead of an E.org. From here near the top right, we can click on the manual to get more documentation on Slic3r. From here we can see how to use Slic3r as well as get various 3D printing concepts and tips. Documentation on how to use Slic3r from the command line can be found from the list on the left side under Advanced Topics, where we can click on command line usages. If the terminal documentation does not match up with the online documentation, then I recommend referring to the documentation from the terminal that we looked at earlier. For documentation on Ultimaker Cura, we can open up Ultimaker Cura, and then from the Ultimaker Cura Help menu, we can select Show Online Documentation. This will take us to the official documentation for Ultimaker Cura. The documentation for Cura includes instructions on how to use Ultimaker Cura, explanations on what the different settings mean, tips for 3D printing, and more. In this video, the 3D printer I used is the Ender 3 Pro, which as of right now is around $200. Keep in mind, there's a big variety of printers with various prices and features. Creality is the brand that makes the Ender printers. For filament, the price typically ranges from $20 to $30 give or take depending on the type of filament and how many spools are being bought. There's even multicolored filament with fun, vibrant colors. Now I will cover formatting external storage on Androids, Chromebooks, and PCs. In my case, for the Ender 3 Pro, it was only able to read from an MS-DOS partition table that contained a FAT32 partition. First, I will cover formatting external storage with an Android. For my case, the following solution for Android formatted the external storage with an MS-DOS partition table that contained a FAT32 partition. To do that, we can first plug in our external storage device. Then after that, we can open up Android Settings. Then from Settings, we can scroll down and click on Storage. Then from Storage, we can click on the This Device pull-down and select the external storage. From here, we can click on the three-dot menu from the top right, select Format, and then click on the Format button from the bottom right of the screen. After that, we can click on the Format button to confirm that we want to format the device. Keep in mind that formatting the device will erase everything that's on the external storage device. When that's done, we can click on the Done button. So now the external storage has a MS-DOS partition table with a FAT32 partition. On a Chromebook, in order to erase the existing partition table, I used the Chromebook Recovery utility. Then to format the storage as FAT32, I used the Chrome OS Files app. To get the Chromebook Recovery utility, we can open the Chrome OS Chrome browser, then go to chromewebstore.google.com. From the Chrome Web Store, we can search for Chromebook Recovery utility. After that, in the search results, we can click on Chromebook Recovery utility. Here we can click the Add to Chrome button, and then we can click the Add Extension button. When that's done, we can close the notification that says the Chromebook Recovery utility has been installed. Now we can plug in our external storage that we want to format. After that, we can open the Chromebook Recovery utility by clicking the Extensions button that has the puzzle piece icon near the top right of the Chrome browser. From Extensions, we can click on the Chromebook Recovery utility, and then we can make the window full screen. Now to wipe out everything that's on the external storage device, we can click the gear icon near the top right, select Erase Recovery Media, then in the Select dropdown we can select our external storage. Once we've selected our external storage, we can click on the Continue button near the bottom right, then click the Erase Now button. When that's done, we can click on the Done button, which will close the Chromebook Recovery utility. When that's closed, we can then also close out of the Chrome OS Chrome browser. Now to format the storage to FAT32, we can open the Chrome OS Files app, and if the external storage is not listed from the left side, we can unplug it and then plug it back into the Chromebook. If we click on the device, we will see the file system cannot be opened because we've erased everything. From here we can right-click the external storage, select Format Device, and in the dialog that comes up we can set the drive name, and then set the format to FAT32. When that's set, we can click the Erase and Format button. Now after the storage is formatted, if we click on it and see that the name is not what we had set it to be and the files that had been wiped out still exist, then we can click on the Unmount button that is to the right of the storage device, unplug the storage from our Chromebook, plug it back in, and now we should see the new name of the device and we should see there are no files on the external storage. So now we have successfully formatted the storage to have a FAT32 partition. Finally, on a PC, to format external storage to have a MS-DOS partition table containing a FAT32 partition, we can use gparted. If gparted is not already installed, then we can install gparted. So first we can plug in our external storage into our PC, then in any pop-up windows that come up, we can click on the OK button, and then we can close out of any file manager windows. After that, we can open up gparted from the menu, And in the System Tools category, we can click on Gparted. From here we will need to type in our password in order to open Gparted. When Gparted is open, we can make it full screen, and then we can select our external storage by clicking on the device dropdown from the top right, and then select the external storage. Make sure the external storage is selected because we do not want to wipe out our main system. Here we can see the types of partitions the device has. Before we format the device, we can also view what the partition table is set to by going to the View menu, select Device Information, then from the panel on the left we can see what type of partition table the device has. If the device is not already formatted to what we need, we can first unmount each partition by right-clicking on the partition, and select Unmount. When all the partitions from the external storage are unmounted, we can delete all the partitions by right-clicking on a partition, select Delete, and once all the partitions are ready to be deleted, we can click the green checkmark button near the top left to apply the changes. From here we can click the Apply button to confirm the change. When that's done, we can click on the Close button. Now to format the external storage as FAT32, we can click on the Device menu, select Create Partition Table, and then in the Select New Partition Table Type dropdown, we can select MS-DOS. Once we've done that, we can click on the Apply button. After that, we can right-click on the unallocated space, select New, and from here we can click the File System pull-down, and select FAT32. From here we can also set the label. Once we've done all that, we can click on the Add button. Now to apply the change, we can click on the green checkmark button near the top left, and then click on the Apply button to apply the change. When that's finished, we can click on the Close button, and then we can close out of Gparted. So now the external storage has an MS-DOS partition table that contains a FAT32 partition. Quick tip for Ultimaker Cura. If you sliced the cube with Cura and the resulting cube has a zigzag pattern on the outside, I've found that setting the infill to have a triangles pattern gives the cube a more uniform look. The setting is available from the Print Settings dropdown. Click the Custom button, then click the Infill dropdown and set the infill pattern to triangles. Different settings can have different effects. I recommend experimenting to find out which settings work best for you. Fun fact, RepRap is short for Replicating Rapid Prototyper, and it is a project for developing 3D printers that are low cost and can print most of their own parts. Here I got a chuckle out of the picture showing the parent machine that created the plastic parts for the child machine. Companion books to my series of videos are available. I will have those linked in the pinned comment. And that's all for this video, so thank you for watching, and I'll see you soon!